Module F, lecture 2. In first lecture, we discussed about various aims of traffic assignment procedures, why we do the traffic assignment, what are the outcomes, then the three aspects what we should bear in mind, like the person trip versus vehicle trips, diurnal demand or the time of the day variation of the demand, and the direction of travel. So, use of OD matrix rather than production attraction matrix. These three aspects we mentioned very clearly that one should keep those things in mind while answering to any questions related to traffic assignment. Then the link cost function, we said that how important it is and what is the link cost function as the for a given link, how once the demand changes, how the travel time varies, and that is what is represented by the link cost function. And then talked about how the network is defined with reference to say taking an urban road network, what are the components, link node diagram representation, then how the transit network is represented, then interzonal flow and the link flows, how we can calculate a link may be part of multiple paths with respect to different OD pairs, then the centroid and how the centroids are connected using the centroid connectors or simply the connectors to the basic road network. So, we shall continue our discussion today. Now, before I proceed further, let me spend a few minutes just to give you a kind of understanding how the network develops. Think a small, not even a town, but maybe a settlement mostly in the rural base, where you have one or two major motorable roads passing through that area, and the remaining roads are not all weather roads or not the motorable roads probably. Yes, people use them as road, but they are just foot track or maybe I mean you can walk or you can go with a bicycle, at best with a bike, but not by car or four wheelers. Also maybe throughout the year this road may not be you may not be able to use these roads. So, those are represented by yellow. So, that look at the stage 1. So, the yellow line indicates are the real all weather proper road, which in engineering sense is a road and all weather facility. Also, the yellows are other roads, which are people call it road, but they are not really in true sense engineering structured that way. That is the condition. So, people go from one house to another house or one village cluster to another village cluster using this kind of informal roads, right. And then you have one major road, maybe a state highway is passing through or MDR is passing through that area, and that is the road which is a proper road. So, then at this stage 1, the first attempt is what? The first attempt should be develop the road network, so that all these nodes, if we consider all these nodes as village centroids or so, right. So, we want to then develop this network further to the best possible extent, primarily to satisfy the target of what? Target of ensuring connectivity to all these nodes. Connectivity was also there earlier, but they were not using proper roads. So, now we should have all weather road connectivity to ensure that all the nodes are connected. So, that means my first target should be what? How to build minimum number of links or total road length. Okay. Minimum in the sense that we do not want duplication. So, nowhere there will be any loop, you cannot access one node using alternative path, but at least just you are able to ensure connectivity. So, any point to any point you can travel, but then there is no alternative path for traveling to any node. That is stage 2, that is the immediate target. So, most cases the rural base we are targeting that, the whole PMGSY in a gross sense is aimed for that, trying to ensure rural road connectivity using all weather rural road connectivity. That is the first stage. So, yes, I can travel from any point to any point, any village to any village, any settlement to any settlement using all weather motorable road. That is the stage 2, but there is no alternative route. So, at least the minimum that if I can maintain, my connectivity is maintained. So, all what we need to do is to ensure that network is maintained throughout the year. But then more and more people start living there. So, this network may not be sufficient. Some cases people have to do a lot of detouring because there is no alternative route. So, then you start making more and more roads, that which earlier you had to detour and take a much longer distance, travel much longer distance to reach. Now, these 2 points are connected directly, because you realize so many people want to travel from this point to that point. So, a direct connectivity is necessary. Like that, then you keep on adding more and more links, because of the demand is growing and your current road does not have capacity, or current road system is okay in terms of capacity, but you know the people have to travel a longer distance, it requires a lot of more time to travel. So, you want to make the connectivity or the travel faster, with minimum time people should be able to travel. So, you start developing the network. So, once you develop the network, then it comes to a network like urban network, alternative paths. Now, not just connectivity, but you can still travel using multiple path, alternative path. An intermediate stage could be some small towns, little bigger than that. Such number of paths are becoming, where alternatives are available, becoming more and more, because more and more roads are getting built. And finally, if you reach to metro like Calcutta, Bombay, Delhi, virtually any point to any point you want to travel, you have alternative path. Any 2 point, most cases you will find, maybe 90%, more than 95, 99% case, you want to travel from point A to point B, you can travel using alternative path. May not be through and through alternative path, but some segments may be little bit common, but still significantly different alternatives are available. That is stage 3. And any city, any town, any urban areas could be somewhere between stage 2 and stage 3, better than stage 2. The highest level is stage 3, where practically nearly 100% OD pair you have alternatives, and then in between all other cities and towns will be there. Somewhere maybe for some OD pairs you have alternatives, some OD pairs you do not have, and then the proportion of OD pairs where you have alternative links may increase as the city grow, and cities are growing, and as more and more infrastructure is being built. So, finally, it comes to a shape, as I say, near or around stage 3, right, where you have alternative paths. Most urban cases you want to travel, you have alternative paths. So, it is useful at this stage to look at some of the network properties, because I mentioned about stage 2, that where you have you are ensuring connectivity with minimum road length, that I construct so many minimum road length I should construct, so that my all nodes are connected. just ensuring connectivity with minimum route length. That is the minimum spanning tree. And then finally, as you are moving towards stage 3, then you want to assign traffic. Stage 2, traffic has got no alternative. If somebody has to travel, it is travel along this path only, because there is no loop, no alternative link. But as alternative starts coming and more OD pairs you have alternatives, then the shortest path become important, because every one of us, each one of us individually would like to think which is the shortest path, and we want to travel along the shortest path. Right. So, these two things I will discuss, because I mentioned about this stage 2. So, I want to discuss about minimum spanning tree and then go to shortest path. So, with these algorithms, once we know this, then we will go to the next stage, actual traffic assignment principle. So, what is the minimum spanning tree? As I said, that to ensure connectivity of n nodes, n number of nodes, if I have to connect, minimum number of links, how many? N minus 1. So, I need n minus 1 link minimum and only n minus 1 link, because I do not want any loop to happen. Alternatives are not available. You want to travel from one point to another point, all point to all point you can travel, but no alternative. So, exactly then I will require minimum also n number 1 link to ensure connectivity, and exactly n minus 1 link only, because I do not want the loop to happen. Right. Now, in a network there are so many ways you can select n minus 1 link to ensure connectivity of n nodes. Now, in each case maybe the total length of all the link, total length will be different. I want to pick up that n minus 1 link, that set of n minus 1 link, where the total length is minimum. What is the implication, or why I want to do that? That implication is, that means if suppose the development authority or the government has to ensure connectivity, they would like to ensure that with what minimum route length, because I can generally consider cost is proportional to the length of the road. Right? If you have to make 200 kilometer road and 220 kilometer road, making 220 kilometer road will be costlier in general. Right? So, I want to have minimum length or total length of the road to ensure connectivity of this. So, I am optimizing in terms of my total length of the network, that I have to construct, that I have to operate, that I have to maintain properly to ensure this connectivity. So, that is what is the minimum spanning tree. N minus 1 link to ensure connectivity of n nodes with total minimum length of the links, n minus 1 selected links. That is what it is, I have shown here. Okay. So, you can ensure connectivity. If there are say 6 nodes, there are so many ways I can select 5 links, and each case my all 6 nodes would be connected using exactly 5 number of links. But among those alternatives, there will be one where the total length is minimum. That is what is the minimum spanning tree. So, there are 2 important features of minimum spanning tree. As I said, that development of something like a minimum spanning tree is the first objective. Right? When a rural base or rural area is getting developed, slowly more and more population trying to get developed to a more formal or going to some kind of urbanization is happening, because all these developments happen slowly. The city of Calcutta was once again also probably started, yes, it started with villages, a set of villages. Right? So, every place, the big towns, big metro cities, they all started once upon a time with a cluster of villages. So, this the way that it gets developed is again very interesting. So, two important feature. First step is again getting the minimum spanning tree, but that is the basic minimum requirement. If people have to live, they should be able to travel from any point to any point using all weather motorable roads. That is the first objective, and that we can achieve using minimum spanning tree. Now, there are two important features of minimum spanning tree. One is the possible multiplicity. Just consider that every link, theoretically speaking, every link the cost is same. So, there are multiple solutions, because every spanning tree is a minimum spanning tree, and I can have so many alternative minimum spanning tree. So, possible multiplicity is there. So, similarly, some of the links may be think there also we can get alternative solutions, but if each edge has a distinct weight here in this case is let us say length we are talking. So, let us say length of each link is different, then there can be only one spanning tree. So, no two link is having the same length. Every length is different or the weight is different. In that case, the solution what you will get for minimum spanning tree is unique. No two minimum spanning tree you can get, right. So, it is only unique minimum spanning tree. So, minimum spanning tree may be unique, also may have multiplicity, possible multiplicity is there, depending on how the edges are there and whether you have proper link costs are same or different, that will govern. So, let us talk about two algorithms. We shall discuss about two algorithms here, how to get a minimum spanning tree from a set of links. Now, this set of links you can think that there are maybe connectivity is there, they are not all weather road connectivity or there may not be there motorable roads. You want to select that, then which are those links which that I should upgrade to a more formal road to ensure connectivity with the minimum spanning tree. So, you can think all are potential candidates. So, that way I have got multiple links, multiple connectivity exists, each case I know the length and I want to decide that which set of link n minus 1 link I shall pick up to ensure connectivity of n nodes. The classical algorithms is one of possibility, the other possibility is the different algorithm, Prim's algorithm that I shall discuss after this. First, coming to Kruskal's algorithm, this is a greedy algorithm, because you will understand, you have to remember all the links and their corresponding length. So, what we need to do, we build a list in a very simple way in ascending order, that means lowest length link on the top, then the next immediate higher one, then next immediate higher one, like that I prepare a list. Then first I take the shortest link, try to see is all my connections are done, no. Then I go, I pick up the next immediate higher link, higher cost link or higher length link. If I find I am forming a loop, then loop is not permissible, not allowed. I put it back, I know that I cannot include, because then I am going to end up with loop. I cannot accept loop, then I reject that, take the next immediate higher link. Like that, without creating loop, if there is a loop, reject that link. New link you pick up, next higher cost link, and you find that it is creating a loop. So, you do not add, you reject that. Like that, I will pick up n minus 1 edges or link, my job is done. I have picked up n minus 1 link to ensure n connectivity of n node. How it works? Let us take an example. Let us see that this is the base network that is given to us. These are all the possibilities. Maybe you can consider these are the existing roads, existing connections that people are using by for walking and for use of bicycle, and they are maybe not blacktop surface, not bituminous road, not concrete road, right, but they are just maybe some as I said, that not really a proper engineering structure, and you want to convert them to all weather motorable roads. So, how to select this? I know I have got A to B, B to D, D to E, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have got 9 links here, 3, 4, 7 to 9. Yes, I have got 9 links. And how many nodes are there? I have got 6 nodes. So, how many links I want to pick up? 5 links. So, from 9, I have to pick up 5 links to ensure connectivity of 6 nodes. That is what is my objective. As per this algorithm, what I will do? I will put them in order. So, let us say E to F, first is D to F, then E to F, A to B, any order, then B to E with 3, then A to C with cost 4, then B to D with 5, then C to E 6, and E to D or D to E is 7. These are bidirectional link. So, no arrow is given, that means two-way links. And of course, when we are thinking of the basic connectivity, we cannot think of one way, two way, right? All roads are two-way roads. So, what we do? First we take the DF, that is the list cost, that is on the top, I pick up. I have only one link, but I know I have to select 5. So, I still need to select 4 more, okay, without creating loop. Next is EF or AB, any one, okay. Let us check EF. Have I formed a loop? No, I have got only taken 2 links and no loop. So, that is fine. Third, A to B, again this also did not form loop. So, I can take it, no problem. Then the next one is B to E, yes, again no loop. Now, next one in that order, what would be the next link? A to C, 4, cost is 4. I got my link. So, here the sequence is such that somehow the loop issue did not come, because the way I selected one by one after another, somehow the sequence was such that none of the link selected had to be rejected because of the loop, that loop issue did not come. So, straightway I could select. Maybe in another case, just the way the numbers are there, you could find that say for example, this any other link, maybe you change the cost, there could be an issue of loop, right. So, it could have been like 4 could have been this maybe E and D is 4, let us say consider, and let us say A and C is 7. Then our next link as per the cost could have been D 2 E with 4, if I assume that D 2 E is 4, but I would not have taken that. Why? Because then already I have connected D to F, E to F. I do not want to connect D to E, because then it will form a loop. Then even if that D is 4, I would have still rejected that and then taken the next one, whatever is the next higher. If it is not forming the loop, I would have taken it. So, here the minimum cost of spanning tree is 12, and you can see that you will not get any other combination of 5 links which will ensure connectivity of all these 6 nodes A, B, C, D, E, F with a total cost lesser than this 12. That is the way this particular algorithm works. So, if I go back again, now you see this is a greedy algorithm. Take a graph with n vertices, keep adding the shortest least cost edge while avoiding the creation of cycles or loop until n minus 1 edges have been added. Without creating load, starting from the least cost link, I need to pick up n minus 1 link without creating cycle or loop. That is what is the Kruskal algorithm. Next, let me show you one more algorithm, which is the Prim's algorithm. Maybe here also let me tell the example first and then come back here. Let us take this example. Same example, what we start? We start with any node in this case, do not start with link. First start with any starting node. Let us say I am starting with node A. I am starting with node A. You can start with any node, no problem, but here in this case example we are starting with node A. So, node A is connected to B and A is connected to C. A to B the cost is how much? 2. A to C the cost is how much? 4. I have not explored any other node, because I do not know still, I have just started from A, I do not know the remaining part of the network. So, A B and A C are the two alternatives, A B 2, A C 4. Which one is minimum? A B. So, I connect it to B. Once I have connected it to B, then my whatever I have explored, A C is still there. Now, B is newly connected. So, B D and B E are new connections, new nodes D and E, which I explore further. Now, what are the cost? A C 4, B E 3, B D 5. Which one is the minimum? B E with a cost of 3. Now, I connect that. And again I am checking also, I cannot form a loop, that check or a cycle, that is continuously you have to check. Then what are my other connections now? A to C is still there with 4, B to D is still there with 5, but now E is also connected. So, E to F is 2, E to D is also 7 and E to C is 6. So, I have A to C 4, C to E 6, E to D 7, E to F 2, B to D 5. Which is the lowest one? E to F. So, next E to F. Then I have now I have explored F also. So, the new edge also I find F to D, that is also connecting D. So, that is another possibility. So, obviously, you can say here the next choice obviously is going to be F to D. Okay. Then whatever are the remaining, the next is going to be A to C with 4, because the other things B to D 5, C to E 6, E to D 7, all are higher than this 4. So, that is why I have again selected, starting from one node, I am exploring the connectivity, and each segment, whatever new links are there connecting to nodes which are still not connected. Okay? I have not reached to those nodes. Among those connections, the least one cost connection I am taking, and like that going stage wise without creating loop or cycle. Cycle I cannot create, because n number of nodes are getting connected with exactly n minus 1 link without creating loop. You can start, I started with A, you could start with B, you could start with C, any node. It does not matter which is your starting node, you will reach to the same answer. So, incidentally both algorithms gave the same answer, but two different approaches. Now, you can quickly see how I described this algorithm. We said start at any vertex on the graph and find the least cost vertex connected to the start vertex. Now, from either A or B, if A is my starting point, okay, and then least cost vertex what I have discovered in that first stage is B, then now either from A or B find the next least costly vertex connection without creating a cycle. Now, again in the same way from either A, B or C find the next least costly vertex connection without creating a cycle, and so on. Like that, actually I will pick up n minus 1 link without creating loop. Fine. So, that gives me this sort of the Prim's algorithm. So, you see how we can get the solution and how the sequence of selection links are different in two algorithms, but the answer is same. Okay. So, that is what it is. So, finally, then to tell the summary, what we discussed here about how the network gets developed. Finally, only a few motorized road or all weather roads, the remaining are not very formal road in engineering sense. And then the stage 2, that time our attempt will be to at least ensure all weather road connectivity to every habitation, and we do not want to create loop, alternative path, but basic minimum road network that can ensure connectivity, and if I can maintain that road network throughout the year, then people can travel from any point to any point. That is stage 2. How to get that? That I said there are spanning tree, that is the minimum spanning tree. Possible multiplicity and uniqueness are that those both are explained clearly, that if I have distinct link length, then uniqueness will be there. If there are multiple links having the same cost, then it is possible that you have alternative solutions with the same total cost. Then two algorithms we discussed, Kruskal's algorithm and Prim's algorithm, which you can use to get the minimum spanning tree. That is stage 2. Then the stage 3. Stage 3 is what? Now, we start building even more roads, because more urbanization is happening, more people are staying, coming, they want to travel. Now, you think like no, a long detouring I do not want, I want people to travel faster using minimum time. So, if I connect this point to that point, lot of people are traveling, then so many people do not have to do so much detouring, they can directly get connected. Somewhere the existing capacity is not adequate, roads are congested, you start building, and finally, you come to a full fledged network development, like as you see in big cities like Calcutta, Delhi or Mumbai or Chennai, right, and where practically any point to any point you want to travel, nearly for all OD pairs you have alternative paths. So, there now the problem will be to find out the shortest path. So, we shall continue our discussion in the next lecture about how to find out the shortest path. Thank you so much.